Myself Dr. W.B. Gyundure from Kamla Mahavidyalaya, Nagpur. Today also I am going to talk on nanoscience and its impact on the society. And today's presentation I am going to discuss the different methods of synthesis of nanomaterials, and after that what are the different methods to characterize these nanomaterials. So today's topic is again now nanoscience and its impact on the society, and today I am going to discuss the different methods of synthesis of nanomaterial. So in this slide there are two approaches. One is a top down and second is bottom up. And the top down method was given by Richard Feynman, who got a Nobel Prize in 1959. And second model, bottom to up, is also given by Jean-Marie Lehn, who also got a Nobel Prize in chemistry in 1987. And both these models suggested that here in top down process we have to start from bulk material and then cut in a proper size or slice it, and then we get a nanostructured material. In case of this bottom up approach, in this now we have to take atom and atom, molecules and molecule, and then cluster and cluster, and finally we get the nanostructured material. Now the scientist Richard Feynman says that there are plenty of room at the bottom, and also this Jean-Marie also says that there are plenty of room at the up. This plenty of room at the bottom or up is also, we can say that just similar to that, we have some one hall, we can divide it into two parts. Also we can divide it into a four part. We can make many parts of one hall by partition. In the same way here we can also do the partition as per our requirement. So there are number, it is a small size particle but having number of compartment, and therefore it is very much useful to the society. So in next slide now this nanomaterial obtained from these different approaches have different types of shapes. Now here in case of first one, the clusters are there, and here these are the cluster, 2 or 3 atoms or molecule come together and forming this type of clusters, which is 0 dimensional. Another is a nanotube, nanofiber, nanorods. So these are the fiber types, these are the rod type, these are some tubes like. So some are the film like or coats, these are the layers, thin layers of film or sheets or coats of this nanomaterial. And the third one is polycrystals, which is 3 dimensional, shown here. So there are different dimensional of nanomaterials. In the next slide, now why do we want to make the thing small? It is because, as we know that if the material is small, then we make things small because it should be a cheaper, smaller, faster, better and easy to handle, and also easy to carry and use in different purposes. We want things small because to introduce new physical phenomena for science and technology, and also the thing is small because there is a change of structure, then change of structure in different chemical and physical properties, also depending upon the size of material. In case of small material in which strong chemical bonding present, where delocalization of electrons are expensive and therefore extent of delocalization vary with the size. So that is why we require the material in small size. Next slide, here it is shown that there are different, this is the properties of in nano region, and 3 approaches are here. One is quantum mechanical behavior, second increase the surface area, third one is a molecular recognition. In case of first approach, now as there is a new technical physics and it changes, show the change in color, transparency, hardness, magnetism, electrical conductivity. Another approach is that of nano region is that new chemical process, and because of this new processes. It shows the changes in melting and boiling point, also shows some chemical reactivity and catalytic yield. In case of biological applications, this third approach, that it show the changes in or combination of these is with that and show the changes in self-organization, repairability, adaptability, recognition. So these are the changes in 3 different approaches. Now, as we know that nano is small size, and also we require small size material, and changes as the size changes, it show the changes in the properties. These are the 7 properties where the nano size show change in color, conductivity and other properties. So one example of if we change the size, then changes the color. So here color is shown, and here is shown, this is the gold, which is also called bulk gold, having melting point, and color is golden. But now as we know that as the size decreases or is smaller size, then we show the change in color. Now here see the color of this 1 nanometer size gold, color is brown yellow. In case of 20 nanometer gold particles have the color red, and in case of 100 nanometer gold particles color is purple. So gold is in a 3 different color. So this is a purple pink color, red color, and this is the brown yellow color. Till now we have seen gold is in a only yellow color or golden color. But now if the size particle is less than 100 nanometer, what is then? Here is a different colors of this gold. Gold is a very beautiful element and used for ornaments also. But now they have different colors. Another size shown by the nanomaterials, which are obtained from gold nanoparticles and with the different shapes shown here, obtained from the microbial sources like fungi, algae, bacteria, fungus, yeast, like that. So now here this is nano triangles, shapes of nanomaterial. These are the nanorods, these are nanospheres, nanostar, nanosquares. So different shapes of the material can be obtained depending upon their sources. This is one example that here indium phosphorus and cadmium selenium, as the particle size changes 4, 4.2, slight change in a nanometer particle size, so they show the change in color. In case of this also, see the different colors. So different colors change is there depending upon the size of that material. So nano sizing also, it is also observed that changes the chemistry. And now here one paper have been published by CNR Rao, their scientist, in Chemical European Journal in 2002. He shows that when the surface of oxide of gold heated, they show this this is the gold particle which is smaller in size, this is larger in size. When it is small in size, they emit carbon monoxide and carbon dioxide. But similar material, but only in a larger size, show the emission of only carbon dioxide, no carbon monoxide, no carbon dioxide. So changes of size also changes the chemistry. These 2 approaches already we have seen, top down and bottom up. In case of top down, we have to slash or cut in a proper way so that we get a nanoparticles. In a bottom up approach, we have to combine atom by atom or molecule by molecule or cluster by cluster, and we get the nanoparticles. So these are the methods of the preparation of nanomaterials, chemical methods, mechanical methods, all these are the methods now used for the synthesis of nanomaterial. So preparation of this nanomaterial, there are 2 approaches already we have seen, top down and bottom up approach. Top down approach is a physical method, bottom up approach is a chemical method, and these are the different chemical methods by which it is possible to synthesize the nanomaterial in the laboratory. Also there are some green synthesis from plant extract, fungi and bacteria. It is also possible by using a plant extract, by reduction process, it is also possible to synthesize nanoparticles or nanomaterials. These are some modern methods, Solgel method, chemical precipitation, hydrothermal methods used for the synthesis of nanomaterial. And now after that So this is the one method, that is the green approach method for the preparation of metal nanoparticles. Plant extract generally used, and in case of plant extract we have to add the metal salt, and after that adding it, and then we have to reduce it, and then we get finally the nano size particles. And green generally the plants are that is medicinal plants used for this purpose, and example here shown. These are the some medicinal plants which shows the reduction of these extract of these plants. We get the silver or gold or any other nanoparticles. So this is the name: aloe vera, tea, and some other datura like that. All these are the medicinal plants by which the extract of these plants used to synthesize, and this is the synthesis of this nanoparticle from this plant extract is a green approach. Another method to synthesize calcium carbonate, and these are the different shapes shown here, and in this case that compound is obtained is calcium carbonate, and we obtain here the different shapes of calcium carbonate, and the synthesis of this calcium carbonate take place under mild condition, that is near neutral pH and low temperature. It is possible to synthesize calcium carbonate also by biomimetic synthesis. Researchers synthesize different products by use of additives. The role of additive is to interact with the calcium ion and provide active site for nucleation of calcium carbonate. It is then agglomerated into mono or macro particles. So this is also one of the approach to synthesize different types of this calcium carbonate. Here now the most important method and commonly used method is a Sol-Gel process technique, and here there are 7 steps of synthesis, and in first step there is a synthesis of first step we have to mix it. Here we have to mix the chemicals, and then mixing, casting, gelation, aging, drying, stabilization. So these are the different steps, and at the end of a stage we get the material which is a what is that, we say that nanoparticles. So these are the different approaches and method shown. So by Sol-Gel method, in this method, this process is a wet chemical technique used for the fabrication of both glassy and ceramic materials. In this process, use of either chemical solution, also known as Sol, that is from solution, or colloidal particle, Sol, for example, from nanoscale particle, to produce integrated network, that is called gel. After drying process, the liquid phase is removed from the gel. This was strongly advocated by scientist Heyman in 1970 and also adopted by Pantin and Mast in 1926. Sol is a liquid of colloidal solution, and gel can be described as solid or semi-solid. Sol can be converted into gel by cooling. The gel can be converted into Sol by heating. So this is one important method of Sol-Gel, which is commonly used in the laboratory for the synthesis of nanomaterial. And next method now again solothermal process, and by using this method, by using autoclave, general reaction is carried out in autoclave, and main important part is a solvent, and under pressure and temperature it can be synthesized. So second method here shown is a solothermal synthesis. This method is also a typical wet chemical synthetic strategy using water or organic solvent as a reaction medium in a sealed vessel, that is autoclave, in which temperature ranges 100 to 240 degrees Celsius. This method is better than other two methods, but the precursor solution is usually non-aqueous. This method has been used in laboratory to make nanostructure titanium dioxide, graphene, carbon spheres, and some other nanoparticles. And third also method is a which is also known as hydrothermal method, which is carried out in a also by use of autoclave. In this method of hydrothermal method, hydrothermal means here, this method includes various techniques of crystallizing substances from high temperature of aqueous solution at high vapor pressure. This is a method of synthesis of single crystal that depends on the solubility of minerals in hot water under high pressure. The crystal growth is performed in autoclave, in which the nutrient is supplied along with the water. The temperature gradient is maintained. At hotter end, nutrient solute dissolves, while at the cooler end it is deposited on the seed crystal, growing the desired crystals. Temperature can also be used in this autoclave up to 300 degrees Celsius. So these are the common methods can be used in the laboratory for synthesis of this nanomaterial. This is a well-known method also. As we know that this is a slow combustion process of synthesis of nanoparticles, or particularly the nanocarbon. This is the lamp, and if you keep a bigger flame, then there is a accumulation of the carbon after long time, after few days or after month. See that there is a continuous deposition of this black color powder. This black color powder, after analysis, shows that it is a carbon nano size. This carbon is nano size. So this is also another method we can synthesize nanocarbon by using this slow combustion process. After synthesis of solothermal synthesis, one example here I have given, that is a tungsten oxide, and we show different morphology. We can take the pure ethyl alcohol, mixed solvent also, pure water, and these are their morphology, how they are showing different nature of tungsten oxide. Another slide now. These are the methods of characterization of nanoparticles. So once we synthesize nanoparticle by using different methods, green method or by Solgen methods or any other method, then it has to be confirmed by using the same TEM or X-ray or AFM. Now this is the method here, which is the same is the scanning electron microscopy. In case of scanning electron microscopy, it gives the information about the particle size on the surface of that material, and same is an electron microscope that images or that give the image the sample surface by scanning it with a high energy beam of electrons. So this is the same which give the information about the surface morphology, or what is the particle size on the surface of that material. Second method after same is a TEM, transmission electron microscopy. So in case of this, it gives the picture or the image of whole body of that material, not only on the surface but give the body of all the complete body of that material. And TEM is a microscopic technique whereby beam of electron transmitted through an ultra thin specimen interact as it passes through the sample, and electron beam illuminate the sample and transmitted beam is give the picture. So these two methods are very important method to know this particle size of this nanomaterial. Another now technique is a AFM, atomic force magnetometer, and here there is a one point, or we can say tip of this magnetometer, and it interact with the surface of that material and give the particle size. So this is the accurate method as compared to other also for this know the particle size of that material. AFM is a very good method. Another is XRD. By using XRD, we get such type of curve, and now B can be calculated from this curve, and T is the thickness of that material, and by using this Chereer formula, it is possible to know the particle size of that nanomaterial. So today we stop here, and we will discuss what are the different applications and also detail about the carbon nanotubes, method of synthesis of this carbon nanotube.